venga, vamos a batería. Vamos a hacerlo un poquito rápido, sería... Coordinar, ¿vale?
Capaz de hacer todo lo que normalmente. Hay que comprarlos, hombre.
Two separate studies, children of the 90s and Framingham, extremely obese to require bariatric surgery or to lead to a series of mature health outcomes. The classic example for explaining a polygenic risk score would be to take height. So there are many, many genes and variations within them that contribute to attained height in an adult. Indeed, if you think about it, there are almost an infinite number of potential biological contributions to how tall we are. So when you do a study of genetic contributions to height, you don't just find that one variant is correlated with height, but many. Now, for any given set of individuals in a population, if you can measure all of those, they will carry different combinations of those genetic variants which have some predictive relationship with attained height. So for some individuals, they might have a relatively high collection of the height elevating variations, and for some people, they might have a relatively low collection, and there will be everything in between. But the score is essentially the aggregate combination of all genetic variants in the genome to the health factor that you're interested in. These are not specific, deterministic, rare mutations which are inescapable. These are, on average, genetic contributions to a complicated health outcome, which indeed are malleable. They can be intervened on. For example, obesity and weight is clearly a combination of energy balance and then also genetic contributions. Now, even if you have a relatively strong genetic contribution, so your score is relatively high, that doesn't mean, of course, that you can't then alter the balance between environment and that to account for that. And of course, all of the data that we do, or we analyse in these studies of the population, are not predicting individual trajectories, but population averages.
So genetic risk score is essentially a compilation of lots of positions in the genome that we know does something to obesity. So it either increases or decreases someone's risk of getting or having obesity. So what we can do is compile all of that data and see whether people at the higher end of that spectrum have an increased risk of obesity and what age that starts at. And that's what we did for this paper.
We all have genetic contributions to all of our physical presentations. Now, some of us will have slightly elevated risk for some things genetically and slightly less than others. Other people will have a different combination, and that's completely natural variation in the human population. The only change really here is that we're able to measure that routinely now. And what's really fascinating is that clinicians have been doing that type of exercise for many, many years, but they've been doing it with physical measurements only. So when you measure somebody's height, if we use a ruler, that gives us a number for height, But that number is, of course, a combination of genetics and environment. And all we're trying to do now is to slowly unpick the relative contributions of genes and environment to understand them better. And that's exactly what this study set out to do.
So what we did in this study was we took the genetic predisposition of obesity at adulthood to see where that actually was observed in this huge amount of data. And we saw that even at age 3.5, people that had this genetic predisposition were already seen to be, on average, a higher weight than those that didn't have this genetic predisposition. And because we see it so early on, in 3.5-year-olds, 4 years old, that gives us the opportunity to then see whether we can change that predisposition later in life by having better diets, better exercise, that type of thing.